In this demonstration, we'll continue working with our intranet site and we'll use business connectivity services to access and edit this data from our customers' database. We have a very simple customer table with 3 customers in it. This time, however, we'll use Visual Studio to build a data connectivity model. We can do this very easily by selecting the Business Data Connectivity Model template. We call our project Customer BCS, validate against our intranet site and click Finish. And Visual Studio creates our first entity for us. The first thing I want to do is rename the code file, the class for entity 1, which Visual Studio has created. So I'll call that customer. This will represent each row in the customers table. Inside the class, we'll set up the public properties. The first thing we'll set up is an int32 property called customer ID, and that will represent the customer ID column. We'll also set up a property for customer name, and we'll add another public string property called city. So these will represent the 3 columns in the table, and we'll represent them as a list in SharePoint presently. Switching back to the designer, we have our entity 1 that Visual Studio created, and we will rename that to customer entity, just so we can identify it when we're building external lists and content types. But we'll also rename the identifier. We'll call that customer ID. We can use the designer to do this, and notice that it updates the name property in the properties window. We also need to change the type to system.int32 because that column is a small int or small integer. Visual Studio has created our read list and read item methods for us, so we'll start working with those. The first thing we'll do is we'll edit the identifier 1, which is our input parameter, to read item, and we'll call that customer ID. We'll change that to a system.int32 as well. Read item is what's called a specific finder, where we can retrieve a row from the database based on an individual ID of the customer. We'll also work with the return parameter. It's currently set to entity 1, but we'll edit that and we'll first of all rename the entity to customer, so the specific finder will retrieve an instance of a customer for us. We should then set up its type descriptors, so we'll rename customer ID to identifier 1 and set its type to int32, because that will be the correct data type for this property. We'll take message and rename that to customer name, and system.string is fine for its type. We'll also add an additional type descriptor for city. So what we have are 3 type descriptors, one to represent each column in the database that we will eventually render and edit in SharePoint. So that's our specific finder method called readItem. Now we'll do some similar work with our readList. ReadList is known as a finder method, and it can retrieve multiple customers for us, or at least it will do when we write the code. So we have as its return parameter a list type to start with, and Visual Studio calls it entity1list, but we'll rename that to customer list. And its subdescriptor is currently called entity1, but we'll say that that's a list of customer types. Now, just as before, we need to set its type descriptors, so we'll first of all set customer ID as its identifier, and we'll change its type to int32. We'll take message and we'll rename that again to customer name, and system.string is fine for that one. And just as before, we'll add an additional type descriptor for city, and system.string will be fine for that. What we have here is readList returns a parameter, and it's a collection of customer objects. So that's those 2 methods configured, and we'll implement the code for them in a few seconds' time. But before that, we'll add an additional method. We could create a creator or a deleter or an updater method, and in this case we'll choose a deleter. And Visual Studio has already correctly configured it so that it takes in the identifier. What that means is that we'll be able to run code based on that ID value to delete the appropriate row. Let's double click read item, and Visual Studio takes us into its sample code that it created for us when we created the project. What we'll do is modify that, but first of all we'll add some using statements for SQL Server operations. And we'll add our helper function called getSQLConnection, and that creates an SQL connection object and sets its connection string to our SQL Server and our customer database. What I can now do then is remove the sample code that Visual Studio added and add my own. It's fairly simple code. The first thing we do is create an instance of the customer object based on our customer class. We open up an SQL connection based on our helper function, and we run an SQL statement with a filter value of customer ID being equal to the ID in parameter for the readItem method. We can then build a data reader and iterate through it, or at least read the first row, seeing as we know we're only going to get 1 row, and populate our customer entity with the appropriate values from the database. We can dispose of the SQL connection and then we will return our customer object. We'll do something very similar for read list. This time, however, we'll create our own generic list of customer objects called all customers. We'll open the SQL connection and run a command that selects all of the customers this time, so not just one customer. And for each row that gets returned, we'll add a customer item to our all customers collection. We can then work with the customer list collection which we return from this function, and very simply we'll just copy the customer objects from our internal list into that collection. We have an exception catcher that provides a single item with a suitable message if we are unable to retrieve data. Now we set up our delete method, and we can implement the code for that. That is really very simple. Remember that we passed in an integer, or Visual Studio set that up for us. So we just need to delete the customer with that ID by running a very simple SQL statement as shown in the method on screen. We can now deploy our solution, and when that's been deployed we can go to Central Administration just to view it. So Central Administration appears, and we can go to Manage Service Applications, go into our Business Data Connectivity application, and there's our entity. That's just been deployed, Customer Entity. So back in our SharePoint site we can now build an external list based on that entity, or our external content type in other words. So let's go to the All Site Content and then click Create. We can then choose to create an external list. We click Create, and just as we saw in a previous demo, we provide a name and we'll call it My Customers. And we select an external content type. We can use the external content type picker, and there's our customer entity that we've just deployed. We can click OK, then click Create, and SharePoint will create an external list based on this external content type. So there's our list, and it's retrieved our data from our database via our Visual Studio project. The list was rendered with the read list method, but if I click a single item and say view the item, the values populated on this form are created by the read item method, so that was the specific finder. When I click delete, our delete method will run. So based on this customer ID, we delete the AdventureWorks customer in Los Angeles. In our list, the item appears to have been deleted, and when we switch back to our data source and click execute, indeed the data source has been deleted from the database as well.